So this should be our final video. We're going to just start in with number 19. So number 19, again, it's wanting us to rewrite these problems, right? I'm gonna work with because it says non-negative here, right? So I'm gonna focus on that first while I see this negative. Now, what does that actually mean, right? When there's a non-negative and exponent, it's actually just 1 over that exponent, or whatever, if we're going to say if it's a -1. So, what we're going to do here, I'm just going to put that at the bottom already. Just so, I'm going to leave again. So, we're going to leave it here, right? So, that's just going to do the bottom. So we're already done with that one. Now we can focus on whatever's positive. Well, we're left with a positive 3, right? And a positive y to the 5/6. And that's all we need to do. Because it says we can use positive exponents. Alright, number 20. Use the laws of exponents to simplify. So with this one, they're just wanting us to get it to a non-negative number, right? So, I am seeing this. Each of these numbers are being risen to the 4th. Right? And don't worry about the negative right now. We're just trying to get this simplified, and then we can make sure everything's swapped. So, 81 to the 4th is actually just what is the 4th root, or what is being multiplied by, or being multiplied 4 times to get to 81. That would just be 3. So then we're left with 3, right? Then 8 to the 4th, we're actually just going to do 8 times 1/4, which is just 2. So k to the 2nd. Then finally we have a -12 times the 4th, which is just -3. Again, they say non-negative. So, our positives stay on top, and our negative goes on the bottom, but it's no longer negative, it's just a positive in the bottom. And that's pretty much what they want to do. They want you to do. Alright, so now for number 21. Number 21 is use rational exponents to simplify. So, from here, basically, we're just going to figure out what we can take out. Well, that 23, if we know 23 is a prime number, there's no factors in it. So 23 is just going to stay under there. So let's just already have that under there. Then, let's worry about the x to the 30th. Again, we're trying to figure out how many groups of 6 x's are in this x to the 30th, right? So basically, we're just doing 30 divided by 6. Which is 5. So x to the 5th. If you're lost there, I'm basically can show you. Just imagine if you wrote 30 x's here. I'm just going to put the first 6. 1, 2, 3, 4, 5, 6. And then just an extra one to show that it continues, right? This is one group of 6, right? 1, 2, 3, 4, 5, 6. That's going to be an x. And then the next 6 is going to be an x. So you're basically just seeing how many groups of x's are in that 30, which is 5. So that's where you get this answer. Alright, number 22. They want us to simplify, right? So, let's factor out, let's see what we have left here of 147, right? That is actually 49 times 3, right? So, actually, we're just going to separate this if it makes more sense. So, 147 times x to the 4th, right? So, that's basically what we're going to be doing here. So, let's focus on this one. 147. That's going to be the 49 and 3. So 49 is going to be under the square root. Draw out a 7. We have 7 cube root 3. Alright, how about our x to the 4th? Well, x to the 4th. How many groups of 2x's are there here? 1, 2. So, x squared. Then our last one is our y. There's no pairs of y. It's just a single y, so it stays the same. So then we're going to join this out. These are our outsides, because they got out of the square roots. They're not stuck anymore. But our 3 and our y are still stuck under that square root. Alright, number 23. 23 is just simplifying again, right? So, what I'm going to do is put these in fractions. I know usually you want to get rid of the fractions or minimize fractions, but actually we're going to make them. So basically what's happening here is actually it's x, right, to the third times 2. So x to the 2/3. And same pattern follows 7 to the third, or 7 over 3, times, we have a x, again, follow the pattern, 5/3, and y, sorry, I forgot the multiply there, and 6 over 3. Yes, I know they're in mixed numbers, but we're going to get there. So then we're going to combine our like terms, right? Because this is what we're going to be multiplying. Right? Well, when you multiply two exponents that have the same base, you're adding them, right? 2/3 plus 5/3 gives us x to the 8/3. Right? How about our y? 7/3 plus 6/3 gives us 13 over 3. Right? So, let's get this back into radical notation. I don't know what happened there. Okay, sorry. What we were left with, you can just go back in the video and get back to this, but basically what we were left with is it was x to the 7/3 times y to the 13/3. Well, we know since these are not multiples of 3, we're going to have some odd things. So we can already leave out a third, or cube root here. Well, think about it. How many 3's can I fit into the 7? 2, right? So x squared. We're left with that odd one out. That's still stuck. Alright, imagine this. How many 3's are in there, right? Then we're left with y to the 4th, right? Because 4 times 3 is 12. And then we still have that one y still stuck. Alright, number 24, again, they're wanting you to simplify, right? So basically what you're seeing here is actually, again, splitting like I did in class. This is the same thing, right? And then we're going to do the square root of 25. That's just 5. And then we're just going to pull these out. Well, square root, we're going to pull out, this is actually, it's a 36 times 2 for 72, if that makes more sense. So we're pulling out a 6, which is what 6 times 6 is for 36. And then we can take out, right, 4 divided by 2 is just x squared. Y divided by 2, well, we still have a thing stuck here, right? So then we're left with a y, just a y. This is all we're taking out here. Actually, that's not true. It's y to the 3rd. And our 2 here. So I hope that makes sense. We kind of did our factoring tree over here. Alright, our final one, rationalize the denominator. So this is where we want us to see it's 49 over square root of 13. So we're going to multiply by 13, square root of 13, right? To get us the wonderful fraction, right? Which this is actually just 7. So 7 cube root 13 over just 13. So yeah, that is your review for test 3.